is Issey Masuda, who will present this paper, who has not been presented yet in this conference, the CVPR 2016 paper called Visual7W. I think that now Issey will explain us what does this 7W mean, right? Okay, so the floor is yours. Thank you very much, Issey, for preparing this.
Okay, so welcome everybody. I'm going to present this paper by Yuke, Oliver Groth, Michael Bernstein, and Fei-Fei. And as always, you have here some interesting links, the archive with the paper. They have some kind of web with some resources and some tools in GitHub. But before we explain you the paper, let me give you a little bit of context in terms of visual question answering as a whole. So what is actually visual question answering, or what is its goal? And what we want to do here is, given an image and a question, we want to predict the answer of this question. And the question is always related to the image. So hence the name visual question answering. And actually, the motivation of this kind of work, they've commented that in the paper, and I've also read that in other papers and articles, and it's quite interesting. They are saying that, okay, nowadays with this kind of deep learning, we are solving some computer vision problems like image recognition or detection with quite good accuracy. I think nearly human accuracy. But when we try to solve problems with more like deeper understanding of what is actually happening or what is in the image, the accuracy is not that good. And so they're proposing these visual question answering models to kind of evaluate how good these artificial intelligence models understand the image by itself. So this kind of a new Turing test, and well, some artificial intelligence in the cinema. And well, this is the motivation of the problem. So now that we've seen that, let's go to this paper. And Visual7W, why it's 7W, and they are trying to, all the questions they are trying to solve with this model are what they call 7W, and it came from what, where, when, who, why, how, and which. And they are having this idea based on these newspapers, or one journalist, 6W, I think it's the right ones, and they've had this which question. And well, the questions they are addressing are always so one of these categories, and they are multi-choice. So the question, when you try to solve this problem, you're giving the question, the image, but also 4 answers, and you have to choose which one of them is correct. So it's not open form, which is another kind of question type, but just multi-choice. So 4 candidates, and only one of them is correct. And the special thing about this article is what they called grounding. And well, they are saying, okay, there are other people doing some visual question answering models, but all of them are lacking. They are addressing the problem in the global image. I mean, they're extracting visual features for the whole image, but they are saying, okay, sometimes and usually the questions are related with some specific regions of the image, and this kind of linking is done thanks to the nouns in the questions. For example, why is there foam? So you have this noun here, and it's kind of telling you where in the image you should look. So foam, if you can detect where foam is, you will have a region in the image which is more interesting, let's say. So they haven't introduced that term, but they're using grounding, which is linking image to text correspondence. Yeah, and they are trying to exploit these relationships. And also, they introduce using this grounding method, they introduce a new type of question. They're saying, okay, the typical visual question answering is giving a question and an image. I give you a textual-based answer. But now that we have these groundings, these links between objects and words in the questions, we can propose a new kind of answer, which is what is called pointing. And the answers are actually regions in the image. So it's not text. It's which pillow is farther from the window, and the 4 options are these bounding boxes, and you have to choose this one, the correct one. So they have these 2 kind of questions: telling questions, which are the regular ones, and pointing questions. And well, this is their kind of what they are trying to solve and their new what they have introduced and some related work related with them. This is actually a kind of common approach of what I've read from other papers, and what people are trying to do is, okay, I have the image, I use some kind of model to extract these visual features. I also have the questions. I usually do an embedding of these questions, so I'm trying to project the sentence into a space where it has some semantical meaning, and then you merge these two features and you give it to another kind of model or layer to predict the answer. And it's this kind of the common approach, and we'll see that what they propose is a little bit different from that. And they also presented to do all this new visual question answering with pointing questions and using this grounding system. They presented they created a new data set, which is composed, well, you have here some numbers, but basically the important thing is that they added these object bounding boxes, which is they've taken all the questions they have and they extracted all the objects from the questions, all the appearing words, and they created the bounding boxes in the image related to this question. So here's a little bit the procedure they follow to do this, because they've been a little bit quite picky in how to do this data set and testing human accuracy and blah, blah, blah. And well, they actually use AMT, Amazon Machine Turk, to create this data set, basing on the visual question answering data set, which is kind of the biggest and more used one. And well, here you can see that they're extracting these object names and the bounding boxes for each one, which is the new thing. And the model, which is kind of the important thing here, they actually haven't explained really how their model work. It's a little bit confused. They sell you the data set, but they don't explain you how are they using it. But they have two questions, two kind of questions, the pointing questions, which are answered with a region, and the telling questions, which are the regular ones. And they have two different models for each one. And they are using, I think it's quite used in natural language processing, the encoder-decoder architecture. And what they are doing is the encoder part is common for both pointing and telling questions, and then they just change the decoder part. So what they are doing is, okay, I'm taking LSTM, which is a kind of a flavor of recurrent neural network, and they take the image and they extract these visual features using VGG16. Actually, they take the last fully connected layer as a feature map, and they use that as a kind of the first word of the question, and they give it to an LSTM word by word to create kind of a whole embedding of both image and the question. And once they found the question mark, they stop feeding the LSTM. And once they have this, they also use, and here's another important thing, what they call attention-based models. So this is not like a vanilla LSTM. They are using these attention models, which is, okay, where in the image I should pay more attention in order to predict the answer. And to do that, they are taking previous state of the LSTM and doing some mathematical operations to create these attention maps. And they merge that with the image, and they feed with each word this kind of mask of the image. Whoops, sorry. No. Oh, yeah. Stop it. Just go back. Yeah. Okay. Sorry. And this is the common part, the LSTM, and creating this embedding of the image and the whole question. And what they change in terms of the pointing questions or the telling questions is the decoder part, which is this. For the telling question, it's just the softmax. So when you have the embedding, you just give it to a softmax and try to predict which of the four answers is the most probable. And if you are doing a pointing question, what they do is take the region, which is, these are the answers that they gave you. So these are the four possible answers. And they take each one of them and give it to the same VGG16, extract the visual features. Here they are doing a dot product from these visual features of this region and the embedding of the whole question plus the whole image, and they give it to an LSTM, to the softmax to predict which one is higher, has higher activations. And well, here you can see some of the activation maps that they kind of visualize to see if they actually focus on the objects that they are mentioned in the question. So here you can see that the answer is cake, and yes, you kind of have some higher attention in the cake region. And in training time, they in the telling questions, they do some kind of weird stuff, which is they give first the image as the first word, and then word by token word to the LSTM. And when they finish with the question mark, they start feeding with the answer. I didn't understand much why they did that, but well, that's what they do. And okay, of this model, yes, they do some experiments here, and basically they test this model with 4 kind of subjects. The first one are humans, which is just to have this kind of ground truth or human accuracy, and they also try with logistic regression model, vanilla LSTM, and this is their model, which is the LSTM with this attention model. And for each one of them, they do 2 different kind of tests or experiments. The first one is I'm just giving you the question, and of course the possible answers, and I want you to predict the answer without seeing the image. And the other one is the regular one, which is given the question and the image and the answers, predict the answer. And they do that because they are trying to see how related in a way are the questions to the image and the impact of seeing the image in order to predict the answer. And there are some results, and some of them are quite funny. I don't know. Yes. So you can see that sometimes the machine, this algorithm, is better at answering when they only have the question. And they said that acts opposite as humans. And they said that maybe this is because humans are not kind of trained as the model, so we don't have this kind of prior knowledge of, or a statistical model of the most probable answer, but the machine does, or the model does. So they are better at answering without the image, so only when they given the question. But when you have question and image, the human is much better. And you can see like a huge gap between between the human accuracy and the model accuracy. And this is a comparison between this visual question answering is the kind of the challenge, and they have this big data set, and then the Facebook baby, it's only for text-based question answering. And well, conclusions of this paper, well, they presented this visual question model and they have 2 kind of special things or new things. The first one is this attention model that tells you how to focus or focus on some specific regions of the image. And the other one is that they created this whole data set with images, questions, answers, and also the bounding boxes of the objects appearing in the question. And I think they also have opened a challenge, but I'm not sure that there was some mention in the website. And well, that's it. Thank you very much. If you have any questions.
Thank you very much, Issey.